Right, so then the last part. Now we're going to be graphing the natural log y equals ln of x, or you can be also remembering that as log base e of x. Let's first remember what we know about logarithm functions in general. So here's an example that we're going to graph together. Well, first thing you should remember is that whenever you take log of 1, no matter what the base is, it's always equal to 0. So we start with 1, 0. And then another number I can plug in, and for the x, easy one, is 2, because 2 to the power of 1 is equal to 2. Therefore, my y value would equal to 1, right? What's another easy one? Well, if I do 3, log 2 to the power that gives you 3, it's not very easy to come up with. So why don't we do 4? 2 to a power that gives you 4 would be 2, so then the y value would be 2. And then another number is 8. 2 to the power of 3 is equal to 8. So once you plot those, I want to do one more. I emphasize this while we're back in class. We can actually go into negative y value if you think of the fraction. What about 1/2? 2 to what power will give you 1/2? That's -1. And you can also do 2 to a power that gives you 1/4, which is going to be -2. So you can actually add one more, 1/4 and -2. So then 1/2 is over here down to -1, 1/4 closer to 0 down to -2. Therefore, your graph will look like this. Okay, so then your logarithm functions, right, generally had an asymptote, which in this case is at x equals 1. It's never going to cross the x value 0. So then domain of this function is going to be all the x values greater than 0. So you can write it as 0 to infinity with open bracket at 0, because that's where the asymptote is. But the range of this function is going to be all real numbers, which is -infinity to +infinity. Then coming down to the natural log, it's going to be very similar, right? Natural log is same as log base e of x. And again, logarithm of 1 is always equal to 0. Then the next part. What about another x value that we can put? Well, we know that e to the power of 1 is equal to e. So then if x value is equal to e, which is this e right here, if x is equal to e, what's the exponent? The y, which is 1. So again, keep in mind, the y is the exponent here. Then I can also plug in e squared. That's when you have log base e of e squared. So then what exponent raised to a base e will give you e squared? That's going to be 2, so then the y value would be 2. And let's plot these points. The value of e is approximately 2.718. Value of e squared is approximately 7.389. So I have 1, 0, 2.718, 1. So this point is e, 1. Then e squared is 7.38. So 7, a little over 7, up to this value right here, e squared, 2. So then it goes this way. Well, let's go also the other way. What about all the numbers here? We can go a little smaller than the e value, right? Here, we started with base 2 logarithm, and when we were testing with 1/2, 2 to power of -1 is equal to 1/2. So we can try out 1 over e, and e to the power of -1 is equal to 1 over e. And this value is approximately 0.368. So a little to the over of 0 down to -1. And if you continue to 1 over e squared, this will be -2, and that value will just be even smaller. So then you will have your natural log graph looking very similar to logarithm graph. And this will also have your asymptote at x equals 0. So then the domain of this function would also be 0 to positive infinity with open bracket at 0 because of the asymptote. And the range will be negative infinity to positive infinity, or all real numbers. Okay? So if you were to graph its transformations, right, with shifts left and right, up, down, you can apply the same transformation to natural log just like all other logarithmic functions. Just keep that in mind, okay? And now the problems relevant to graphing logarithmic functions or natural log, there are 69 through 73 in your final review packet. So I highly suggest that you go to the final review packet and do these problems right now when this graphing is fresh in your mind. If you have any questions, then you can always ask me and I can definitely go over them during the Zoom sessions too. Okay? Good luck.